the integral of cotangent of x times the ln of sine of x dx. So the first thing we want to do here is notice that cotangent of x is the same as 1 over tan of x. And this is the same as 1 over sine of x over cosine of x, because tangent of x is sine of x over cosine of x. And this will be simply cosine of x over sine of x. So that's the first step to simplifying this integral. We have the integral of cosine of x over sine of x times the ln of sine of x dx. We can also simplify this further by turning the sine of x into a u. So let u equal to sine of x. This means that when we differentiate it, du over dx, that's going to give us cosine of x. So du is cosine of x times dx, and dx is going to be 1 over cosine of x times du. So what is our dx going to be? Well, dx is 1 over cosine of x du, so we're going to substitute that in. So this cosine will cancel out with this cosine, and we also want to turn the sine of x into a u as well. We will end up with the integral of the ln of u over u times du. You might recognize this integral from our previous examples. So in order to solve this, you have to use u-substitution again. So let v equal to the ln of u. So differentiating it with dv over du, that's going to be 1 over u. So u times dv is equal to du. So over here, we're going to have the integral of v over u, and du is going to be u times dv. So this is going to be u times dv. And now, as you can see, the u's will cancel out, and we have the integral of v dv. So the antiderivative of this is simply 1 over 2 v to the power of 2 plus c. We change the v back to the u, which gives us 1 over 2, and v is basically ln of u, right? So we have ln of u to the power of 2 plus c. And now we change the u back to our sine of x. We will have 1 over 2 times the ln of sine of x to the power of 2 plus c. So that's basically it for today. I hope you guys enjoyed this video. I hope you liked it. If you did, don't forget to hit subscribe. And in the next video, we will go over integration by parts.